In the previous movie, we showed you some common problems that can befall inexperienced riggers. In this movie, we'll start building a more robust rig for this character, starting with the torso. Open the file, Character Rigging, Part 2 Start. Our Emma character is made up of one mesh, along with separate head features, such as her eyes, hair, and teeth. We'll be splitting our torso into two major parts. The main result spine will be driven by an IK spline, which will give us realistic torso movement when controlling the shoulders or hips. On top of that, we'll be adding an FK spine, whose rotation will provide us more minute control over specific sections of the torso. However, before we can begin rigging our torso, we'll need to do something with all this character geometry. As you may recall from part 1 of this tutorial, animators often like to work with lightweight rigs that omit the majority of the skinning envelope and binding to improve performance. These rigs are known as proxy rigs. Thus, we're going to slice up this geometry into sections that will each follow a corresponding joint. This will help us better preview their movement, as well as approximate the character's volume in various poses. To start, switch to Face Selection mode. Using either a marquee or lasso selection, highlight all the faces of the left arm from the wrist up to her t-shirt sleeve. In the Polygons menu set, select Mesh Extract. Maya separates the selected faces into their own mesh. Using the same technique, extract the right arm, legs, and head as shown here. For your convenience, we've included a version of this scene in the lesson materials linked in the description. Select the entire character and select Edit Delete by Type History. Then rename the geometry appropriately. And reparent them so they're all at the same level under the Emma Geo group node. Delete all the empty nodes. While you're at it, parent the head features in this group as well. Middle mouse drag the torso geometry out of the main geometry group, then hide the Emma Geo group. Now we're ready to create our spine joints. Switch to the Animation menu set and select Skeleton Joint Tool. Go to the side view. We're going to create a series of 7 joints for the IK spine. Turn on X-ray joints mode so we'll be able to see them through the mesh. Starting from the middle of the waist, click to create joints heading up to the arm socket. Try to keep the joints as evenly spaced and straight as possible. In fact, if you want to keep them perfectly straight, you can hold Shift as you create subsequent joints in the chain. But it's okay if they bend just a little. Just try to avoid outright following the curvature of the back. To adjust joints as you create them, press the up or down keys to navigate through the joint hierarchy, and then middle mouse drag to reposition the selected joint. Press Enter after placing the 7th joint to complete the joint chain. You can further reposition any joints you aren't happy with by selecting it in the Move tool and pressing the Insert key to go into pivot mode. When you're finished, press Insert again to exit pivot mode. Now we need to slice the geometry to match our joints. Select the torso, then go back to the Polygons menu set and select the Edit Mesh Cut Faces tool command. Hold the Shift key and drag the mouse at your first joint until the cut plane is horizontal. Then release to split the geometry across the line. Repeat this process across every joint. Note that this will create a bunch of n-gons, something you'd normally avoid when modeling. However, since we won't ever be deforming this slice geometry, they won't be a problem here. Now, just as you did with the arms, legs, and head, select the faces of each section of the torso and extract them. You can turn off Show Joints in the workspace if you find yourself accidentally selecting them. As before, delete the history for each object and then rename them. Name the bottom portion Hip Geo, the top portion Shoulder Geo, and the sections in between Spine Geo 1 through 6. While you're at it, rename the joints to Spine Result Joint 1 through 7. Before we parent our geometry, we first need to make sure our local rotation axes are lined up for all our joints. Notice if we select all the joints and select Display, Transform Display, Local Rotation Axes, not all the joints have the same local rotation axes, depending on how the spine was initially created. While the x-axes all point towards each joint's child, the y and z axes differ due to the spine's curvature. Consistent local rotation axes for each part of your skeleton is crucial to the functionality of your rig, as they dictate the rotation plane each joint uses when you rotate it in a specific axis. Here, if we rotate the entire spine chain around the y or z axes in local space, we end up with a crooked spine, as there are inconsistent rotation values from joint to joint. To fix this, select Spine 1 Result Joint and, from the Animation menu set, go to the Skeleton Orient Joint Options window. The controls here let you set the joint's local rotation axis. How you orient them will depend on your pipeline, but it is important that joints in the same chain are oriented consistently. We'll use X as our primary axis, that is, the axis that goes down along the bone towards its child joint. Z will be our secondary up axis, and we'll use positive X as our secondary axis world orientation to make sure the y-axis points forward. Make sure that Orient Children of Selected Joints is turned on so that this new local rotation axis is applied to the entire joint chain. Now all the joints are properly lined up except for spine 7. However, since this is the end of our joint chain, we don't actually need to worry about it since its rotation won't be affecting anything. If you rotate the entire chain once more around the y or z axes, you'll get a uniform rotation. Notice how a positive rotation bends the chain forward? We typically want the positive direction to be the most common bend direction. At this point, we should open the Move Tool settings and turn off the Automatically Orient Joints option, since we don't want to worry about Maya accidentally altering our joint orientations if we need to make further translations. We're ready to create an IK handle. An IK handle will enable us to control just one part of the spine, in our case via a control curve, and have the rest of the spine react appropriately. Select Skeleton IK Spline Handle tool. We're going to use a spline here and not an IK handle. IK handles are great for situations when we want to hold a limb in place, such as a hand or foot planted on a hard surface, and have the body move around it. Conversely, an IK spline will allow us to control the bend of the spine from multiple places at once. You can create an IK spline by clicking on Torso 1 result joint and then Torso 7 result joint in the workspace, or by selecting Torso 1 result joint and then control-clicking Torso 7 result joint in the outliner. Rename the IK handle, effector, and curve to spine handle, spine EFF, and spine curve, respectively. While it's nice that we have our IK handle ready, you'll notice we can't actually interact with it directly. Instead, we have to go into component mode and use the spine curve's control vertices to control it. However, the control vertices are hard to pick and very inconvenient if we had to use them constantly. To that end, we're going to bind the curve to a pair of joints that will act as our controllers instead. To make sure our bind joint local rotation axes perfectly match those of our actual spine joints, we'll create them by duplicating the existing spine. Unparent the duplicated spine 7 result joint and delete everything under the duplicated spine 1 result joint. These are the two joints we'll bind our curve to. Name these two joints hip bind joint and shoulder bind joint, respectively. Now we're going to skin the spine curve to these joints. This will be a very lightweight skinning, so it won't impact performance very much. Select the hip bind joint, shoulder bind joint, and then the spine curve, and go to the Skin, Bind Skin, Smooth Bind Options window. Reset the settings, then set Bind to the selected joints, with Max Influences set to 2, since we only have 2 bind nodes. Click Bind Skin. Select either of the bind joints in the outliner and use the Rotate tool to rotate it. The spine follows along. Now just middle drag the appropriate geometry onto the corresponding joints in the outliner to parent them. And you can play with your spline rigged torso. Now, although this is working, it's still not very convenient to select these bind joints. In the next movie, we'll create a set of controls for the shoulder and hip, as well as add the ability to twist our torso.